Hello everyone, in this video we're going to explore the topic 1.10, 1.11, 1.12 and 1.13 about the discontinuities. Alright, if you look at the picture right here, you see that there's a hole, there's a gap right here. This one is called interruption or discontinuity, right? Now, continuity implies no interruption in the graph, right? Now look at this one right here. 3 examples of discontinuities of a function over interval a and b. Now look at the first one. The picture right here. F of c is undefined, even though the limit of the function f of s when s approaches c is defined, but f of c is undefined because there is a hole right here. You see that? Now 2a right here. The function right here. Limit of f of s when s approaches c does not exist, right? Because there is a jump right here. Look, limit of f of s when s approaches c plus different from limit of f of s when s approaches c minus, right? Now 2b right here, there is an interruption right here, which is the vertical asymptote, right? Now number 3. Limit of f of s when s approaches c exists. However, limit of f of s when s approaches c not equal to fc, right here. So the function is not continuous, right? Now, look at this one right here, the criteria of the continuity. In order for a function f of s to be continuous at a point s equals c, the following 3 conditions must be met. Now the first one, f of c must be defined. Second one, limit of the function f of s when s approaches c exists. And the third one, limit of the function f of s when s approaches c equals f of c, right? In other words, I can combine these 3 elements right here by writing limit of the function f of s when s approaches c plus equals limit of the function f of s when s approaches c minus equals f of c, right? So keep that in mind. In order for the function to be continuous, you must have this gap. Now let's take a look at the first example right here. This is a free response question from the 2011 AB Calculus AB question number 6. Let f be a function defined by f of s equals 1 minus 2 sin s for s less than or equal to 0 and e to the negative for s greater than 0. Question A. Show that f is continuous as s equals 0. Alright, so we're going to use this one right here, right? Now c in this situation is 0, right? This guy right here, right? So we need to check limit of the function f of s when s approaches 0 minus first. 0 minus, which means less than 0, right? So we're gonna pick this guy right here, right? So it's gonna be limit of 1 minus 2 sin s when s approaches 0 minus, right? Now I substitute 0 for s, so I have 1 minus 2 times sin 0. Now sin 0 equals 0, so it can be equal to 1, right? Now second one, I need to calculate the limit of the function f of s when s approaches 0 plus. So I'm going to use the bottom one right here, right? Because it's greater than 0. So it's going to be limit of e to the negative for s when s approaches 0 plus. And then it's going to be limit of 1 over e to the 4s when s approaches 0 plus, right? Now substitute 0 for s, I have 1 over e to the power of 0, right? And it's going to be 1 over 1, right? So it's going to be 1. Now, the first one, we need to calculate f of 0. 1 minus 2 sine of 0. But sine of 0 equals 0, right? So it will be 1, right? Now observe that limit of f of s when s approaches 0 minus equals limit of f of s when s approaches 0 plus equals f of 0. So the function is continuous as s equal to 0, right? Now let's move on to the next one. You may recall from the college algebra or pre-calculus that discontinuities fall into two categories. The first one is removable. The second one is non-removable. Use the following workbench below to fill in the 5 boxes in the table below, right? Now, type of discontinuities. The first one is to be non-removable. And the second one is removable. Now, graphical description. For non-removable, we have a jump and asymptote. For removable, we have a hole right here. Alright, so keep that in mind. It's really helpful for you to do the following problems. Now, example number 1. The graph above is f of s. Determine all s values where f of s is not continuous and classify each as removable or non-removable. Alright, so now you look at this one right here, write f equal -1, right? And you see that there is a jump, right? So we look at the table right here, a jump, which means non-removable, right? And just look at this one right here, you see the vertical asymptote right here, s equal 1, right? So vertical asymptote right here is going to be non-removable, right? So you need to write over here. Next one, we look at this one right here. We see that the limit of the function exists, but it's not continuous because limit of f of s when s approaches 3 different from f of 3, right? So this one is a removable discontinuity, right? So we have a hole right here, right? So s equals 3. And similarly, we have s equals 5, right? Consider the function g of x equal this one. List the s value where g of x is not continuous and classify its type of discontinuity. Write the intervals over which the function g of x is continuous. Right? So we need to find the value of s where the function is not continuous first, right? So I need to factor the numerator and denominator, right? So I have g of s equals, right? On the top right here, I'm going to use s method, right? I need to put -4 on the top and 3 on the bottom, right? This one is C, this one is B. You need to find 2 integers multiply equal -40 add up to 3. It's going to be 8 and -5, right? So on the top it should be s plus 8 times s minus 5. Now the bottom, I'm going to use another s method, right? I put c equal -10 and b equals -3. I need to find 2 integers that multiply equals -10 add up -3, which is -5 and 2, right? So I have s minus 5 times s plus 2, right? If you want to review the old concept about factoring polynomial, please check out the link in the description below. Alright, so I'm gonna cancel out this guy and this guy. So I have s plus 8 over s plus 2, right? So you see that the whole, which means s equals 5, right? Now you need to classify each type of discontinuity. So you have the removable discontinuity s equals 5, right? And non-removable discontinuity is s equal -2, right? Because this one actually the vertical asymptote, right? Alright, next one, we need to write the intervals over which the function is continuous, right? So you need to draw the number line. And you're gonna put all candidates on the number line. The first candidate is s equal 5. The second candidate is going to be -2, right? So -2 is less than 5. You need to put -2 first, right? And this one 5 right here, right? The left hand side you need to put negative infinitive. The right hand side you need to put a positive infinitive, right? Now, in order for the function to be continuous, you need to eliminate the vertical asymptote, right? So you need to eliminate -2. You need to eliminate the whole, which means 5, right? So it's going to be negative infinitive to -2, open parenthesis, union -2 to 5, union 5 to positive infinitive, alright? Or you can write like this, negative infinitive, positive infinitive, eliminate two values, -2 and 5. In this situation, you need to use the curly bracket, right? So keep that in mind. Alright, let's move on to example number 3. Consider the piecewise defined function for h of s below. Determine all s values where h of s is discontinuous and classify each as removable or non-removable. Alright. Now you need to find the candidate of this continuity point. The first one is going to be -2, right? So I have s equal -2. The second one is going to be 1 right here, right? S equals 1. And the third one, 3 right here, right? S equals 3, right? Now, you need to find the limit of the function h of s when s approaches -2 minus first, right? -2 minus, which means less than -2, right? So you're going to pick this one right here, right? So it's turned out to be limit of the function 2s minus 1 when s approaches -2 minus, right? So you substitute -2 for s, so the answer must be -5, right? Now you need to find the limit of the function h of s when s approaches -2 plus, right? It's going to be this guy right here, right? So limit of the function s squared minus 9 when s approaches -2 plus. Alright, so I substitute -2 for s, I have -5, right? Now I need to calculate h of -2, right? So h of -2, I'm gonna pick this guy right here, right? Because I have the equal side right here, look. So it's gonna be -2 squared minus 9 is going to be -5. So you see that limit of h of s when h approaches -2 from left equals limit of h of s when h approaches -2 plus equals h of -2. So then the function is continuous at s equal -2, right? So this one is continuous, but we need discontinuous, right? Now we're going to check the second case. S equal 1 right here. Now we do similarly limit of the function h of s when s approaches 1 minus, it's gonna be this guy right here, right? Because 1 minus less than 1, right? Less than 1 here. So you have limit of s squared minus 9 when s approaches 1 minus. Substitute 1 for s, so it's gonna be -8. Right? Now next one, limit of the function h of s when s approaches 1 plus. It's going to be limit of the function 3s plus 2 right here, right? 1 plus, which means greater than 1, right? So you have 3s plus 2 when s approaches 1 plus, right? Now you substitute 1 for s, so it could be 5, right? Next one, you need to calculate h of 1, right? H of 1, you're going to pick this one right here because you see the equal sign. So it's going to be 3 times 1 plus 2. It's going to be 5, right? Now, since the limit of the function h of s when s approaches 1 minus different from limit of the function h of s when s approaches 1 plus, right? Then the function is discontinuous at s equals 1, right? So you write over here discontinuous, right? Now, we're going to move on to the last one, s equals 3. So we need to find the limit of the function h of s when s approaches 3 minus, right? So 3 minus, we're going to pick this guy right here. So the function 3s plus 2, right? So it could be limit of 3s plus 2 when s approaches 3 minus, right? Now substitute 3 for s, so the answer should be 11, right? Similarly, you have limit of the function h of s when s approaches 3 plus, it's going to be this guy right here, right? So 4s minus 1. Limit of 4s minus 1 when s approaches 3 plus. So substitute 3 for s is going to be 11, right? Now you need to calculate h of 3, right? And h of 3, we look at this one, there is no equal sign. So h of 3 is undefined. Alright, now we need to conclude. This case right here tells us that the function h of s has a removable discontinuity at s equals 3, right? Now for this one right here, limit does not exist, right? So this one is non-removable. And this one right here is continuous, right? So we don't need to worry about this one, right? Now we need to place all these number on the number line. So you need to find the interval where the function is continuous, which means negative infinity to 1, union 1, 2, 3, union 3 to infinity, right? Or you need to write negative infinity to positive infinity is set to value 1 and 3, right? If you write like this, you need to use the curly brackets, keep that in mind. Now let's move on to last question, question number 4. The piecewise function for k of s is below. Find the values for a and b that makes k of s continuous everywhere. Be sure to use the definition of continuity and demonstrate proper notation. Alright, so in order for the function to be continuous everywhere, we need this one right here. Right here. Limit of the function from the left equals limit of the function from the right, and the function is defined right at that point. Alright. Now I have two candidates for this continuity. The first candidate is 2. The second candidate is 3. Right. So I need to write limit of the function k of s when s approaches 2 minus, right? And next one, limit of k of s when s approaches 2 plus, right? Second one, limit of k of s when s approaches 3 minus, and limit of the function k of s when s approaches 3 plus. Now we're going to deal with the first one. Limit of function k of s when s approaches 2 minus, we're going to use this guy right here, right? So it's going to be limit of s squared minus 4 over s minus 2 when s approaches 2 minus, right? Now you need to simplify this one before you're going to plug it in, right? So I'm going to use difference of 2 squared, right? So limit of s minus 2 times s plus 2 over s minus 2 when s approaches 2 minus, right? So I need to cancel out this guy and this guy. And then I'm going to end up with limit of the function s plus 2 when s approaches 2 minus, right? Now I can substitute 2 for s, so the answer is 4, right? Keep that in mind. 2 minus different from negative 2, right? 2 minus tells us that 2 from the left, right? So you substitute 2 for s, and negative 2, which means s equal negative 2, and you substitute negative 2 for s, so you need to be careful. Alright, now the second one right here. It's going to be limit of the function as squared plus bs plus 3, right? Because you have this one right here. So it could be as squared plus bs plus 3 when s approaches 2 plus. Now you substitute 2 for s, so it's going to be 4a plus 2b plus 3, right? This is the second one. In order for the function to be continuous as s equals 2, this guy right here and this guy right here must be the same, right? So I have the first equation, 4a plus 2b plus 3 equals 4, right? Now I'm going to deal with the second candidate right here. Limit of the function KLS when s approaches 3 minus, which means this guy right here, right? So we're going to pick this guy, right? So it could be limit of as squared plus bs plus 3 when s approaches 3 minus. Now you're going to substitute 3 for s. Don't substitute negative 3 for s, be careful. Alright, substitute 3 for s, so it turns out to be 9a plus 3b plus 3, right? Now second one, limit of the function KLS when s approaches 3 plus right here, right? We're going to pick this one. So it could be limit of 2s minus a plus b when s approaches 3 plus, right? So substitute 3 for s, it turns out to be 6 minus a plus b, right? Now in order for the function to be continuous at s equals 3, this guy and this guy must be the same. Now remember that we also need to find where the function defined. So actually the function is defined as h of 2 and h of 3, right? So we don't need to calculate this one because it is one of this one right here, right? So you have, alright, now we need to solve a system of 2 equations right here. Now I need to rearrange this one a little bit, right? So I have 4a plus 2b subtract 3 both sides, is going to be 1, right? Now second equation, I'm going to add a both sides, so it turns out to be 10a, right? And subtract b both sides, so it turns out to be plus 2b, right? And I'm going to subtract 3 both sides, it's going to be 3, right? Now I see that. Now to solve this one, I need to do subtraction, right? So 4a subtract 10a is going to be negative 6a. 2b subtract 2b is 0, right? Equals 1 subtract 3, negative 2. Divide both sides by negative 6, so a equals 1/3, right? Now a equals 1/3, substitute 1/3 for a back to this one right here. So I have 4/3 plus 2b equals 1, right? So 2b equals 1 minus 4/3, which means negative 1/3, right? Divide both sides by 2, so b equals negative 1/6, right? So the final answer is a equals 1/3, b equals negative 1/6. Then the function is continuous everywhere, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun. as she puts her hand in mine.